a nice presentation. So during my presentation, we will go through the different steps of construction. So it's really focused on construction of a floating PV plant, and especially focusing on important aspects that are specific to the floating. So just to briefly introduce Celetaire, which is the well-known pioneer and world leader of floating solar market. So the company was founded in 2006, started developing the floating technology in 2011, and after 2 years, we installed the first 1 megawatt project in Japan. Today, we have over 150 plants connected around the world using our Hydrelio technology. This is our case study for today. So it's a 540 kilowatt peak plant connected in 2018 in Hyogo Prefecture in Japan. This is of course not the biggest installed plant with Hydrelio, but this one is one of the 15 Celetaire has developed, designed, constructed, and is currently maintaining and operating in Japan. The reason for me to choose one of these is because we get to see our product during the entire lifetime of the project and the operation. And it also gives the full picture of what is a floating PV system. We are, by the way, using some of these floating PVs to test new technologies and monitor our plants. For example, we have installed load cells on mooring lines on one of our plants to correlate the wind tunnel calculations and CFD to a real case. And we will soon do the same for the waves behavior to correlate with the simulations. So this plant, as I said, is 540 kilowatt peak. It's using Japan Solar 60 cells panels and Huawei string inverters 40 KTL on water. As you can see, the inverters are on water. In the case of a small reservoir with no waves, our conclusion is that LCOE-wise, string inverters on water is the most economical solution. We don't use 60 cells panels anymore on our plants. We use 70 cells high capacity PID-free modules, and we stick to frame panels. Our experience is that frameless panels are not strong enough for this kind of application. Again, everything that I'm saying is applicable to Celetaire own developed plants, and this is our choices and may not be the choices of different developers. So going now to the main subject, construction activities, the different steps of a floating solar plant construction. I have purposely shown only activities which are related to construction, not mentioning procurement, for example. The first step is the pre-engineering. Pre-engineering is very important. I'm coming to that right after. The anchoring is the second phase, and it shall be the second phase. It shall be done prior to the assembly phase. For big projects, you could start assembly while you are still finishing the anchoring on other islands, but at least you need to have finished the anchoring of the current island while you are starting the assembly. The next phase is the construction and commissioning, and that requires, as Andres said, planning, planning, and planning. It needs to be well planned in advance to avoid any problems on site. And finally, we will finish with the O&M, which is not so much different from traditional PV, but which have small specificities that we will mention. Pre-engineering. We recommend to start with a site visit. So the purpose of the site visit is to identify potential constraints of the site for assembly location, for instance, or for areas that should be avoided. Second step is the bathymetry of the reservoir. So most reservoirs are not flat. Some of them are, but some of them are not. And we need to have accurate depth measurements of the reservoir for each anchor point. It's very important. So we can do an anchoring design which is relevant and which is based on real data. Also, during the pre-engineering, it is recommended to do soil tests to determine which anchors shall be selected and to size the anchoring. Finally, the output of this first phase is the anchoring design of the plants. We can then move on to the anchoring phase. Positioning accurately the anchor points and measure their exact position is key, as I mentioned. So it's not only about having the data, it's about having the exact position of each anchoring points to be able to do an as-built design of the anchoring system. The methodology for anchoring is depending on the depths and soil conditions. Here in Japan, for example, for this site, we are using the barge that you can see on the bottom right part. And this barge is used to drive driven anchors into the reservoir bed. And the depth, for example, of this reservoir is less than 5 meters. So it's quite an easy anchoring for the specific sites. After you've finished anchoring, you have to moor the cables to the. I mean, you have to connect the cables to the anchors. But first, before you connect and before you attach them, you have to verify the mooring lines as built lengths. This is also very important. You cannot base your design on a length of a mooring line which is plus or minus a certain number of centimeters. This simply doesn't work. Then you have to test your anchor points to make sure that the capacity of the anchor meets your design requirements. And finally, you have to compile all the as-built data that you had, the length of the mooring line, the position of the anchors, the loading of the anchor, and everything. And you put that into an as-built drawing and an as-built calculation before you move on to the next step. Next step being construction and commissioning. The assembly sequence must be planned properly, and construction drawings shall be there to reflect the cable arrangements, but also the sequencing. When are you going to install which part of the island? You are not going to assemble the full island in one day. You have to know which part you are going to assemble first, and up to where the cabling will be done on the shore. Then the platform will be loaded out and towed to the site and immediately connected to the anchoring points. If the island is not finalized, you have to connect the sides which are not finalized to some temporary anchors which can sustain the environment loads. That's also very important. We've seen some incidents on some sites where the temporary anchoring was not properly done, and I can tell you it can be a big issue. Next step when the island is positioned is to finalize the cabling, is to terminate the cable. So you can see the state where you are at this stage on the bottom left side. So the strings are pulled. Now you need to connect to the string inverters or to the junction boxes. And very important as well, you need to protect your cables from UV and from the water. This is important. All the cables are not protected by the structure itself, as it is most often the times on the ground system, and it's not naturally protected from the water. So you need to make sure that all the cables are protected from the water, either by being far enough from the water or by being protected inside some cables. Protection, as you can see on the bottom right side. The commissioning I would say the only difference with a traditional PV system is the risk assessment that shall be adapted to water conditions. But apart from that, I don't really see any difference with the commissioning of a traditional PV plant. Now let's finalize this presentation with the operation and maintenance. So according to the O&M manual of the equipment supplier, you have to do some checks regularly on the mooring system, on the support structure itself. I mean, the same as what you have on traditional PV, and it's slightly adapted to the fact that the platform is moving. I mean, it's not a stable environment, it's water. You can have, as Andres mentioned, you can have very small waves, you can have mid waves, and you can have significant waves on your reservoir. So you need to make sure that nothing is moving and the structure is properly maintained, and that there is no significant changes from the initial stage. Finally, you need to do the cleaning of the platform. You need to do some checks on the panels, some checks on the inverters, but that's very similar. From the traditional PV. So I will not mention that. You can see someone cleaning the panels on this picture. You can use the water of the reservoir if the water of the reservoir is clean. If it's not clean, then you need to bring water. What we see on our plants in Japan is that we don't wash them as often as ground-mounted PV O&M people do, for the simple reason that you have less dust, and the dust is often, if the reservoir is big enough, the dust will be catched by the water before it goes onto the panels. The only slight issue that you could have are the birds. And here it's about site selection. You have to make sure that you select the sites on which you have not, you could not have some significant bird problems. We have experienced only bird problems in the UK and in Belgium, but not in Japan, not in the rest of the world. That's about it for me. If you have any questions, please do not hesitate to ask.
Thank you very much, Olivier, for